Welcome to our 9th lecture and the second lecture on IC voltage regulator. In the last lecture, we saw the syllabus for the topic of IC voltage regulator and the book that we are going to use. And we studied these three topics from our syllabus. So the first three topics are over. In today's lecture, we shall look at the other three topics. They are the regulation protection, error amplifier, and series pass transistor. Let us look at each of them in detail. First is the regulator protection. What do you mean by this word? Protection means to protect from what parameters? It will protect from current overload and short circuit, and this is called as current limit. Second thing from which this regulator protection circuits will protect is large differential voltage between input and output terminals. That means the difference of the voltage at the input and the output should be within a limit. It should not exceed that limit. So this protection circuit takes care that that difference does not limit, and that is called as safe area limit. And excessive junction temperature. If the temperature increases beyond a certain temperature, the circuit will malfunction. So the temperature has to be protected, and that is called thermal limit. So this regulator protection circuits protects the IC against overcurrent or short circuit, large differential voltage between input and terminals, and excessive junction temperature. It's excessive temperature within the IC. And these three things are termed as current limit, safe area limit, and thermal limit respectively. Another circuit which provides all these three protection is shown here. In this, let us first look at the current limit. Now in this circuit, Q1 is the series pass transistor. Here you have your input voltage Vs. Here you get your output voltage Vs. And all the current has to pass through this series pass transistor Q1. The amount of current that Q1 will allow to pass would depend on this error amplifier, which gets a feedback from the output and compares it with the reference voltage. Now transistor Q2 is put here to limit the current. And how does it do that? This transistor Q2 will sense the output current. How does it sense? It senses using this resistor R3. As you can see, this resistor R3 is connected between the base of the transistor and the emitter of the transistor. So the voltage developed across R3 is the voltage given to the base and emitter of the transistor. Now if the output current increases, then the voltage drop across this resistor R3 will exceed. And depending upon the voltage drop at R3, the base emitter voltage is the same as R3. So this transistor will start conducting. When it starts conducting, the collector, which is connected to the base of the series pass transistor, drives away the base current or drains away the base current. So when the base current decreases for Q1 decreases the amount of current that it allows to pass. So in that way, the current is limited. Then this circuit will function in the constant current mode. Once again I will repeat. Transistor Q2 functions to limit the current. How does it do it? When the output current increases, the voltage across the resistor R3 increases, and this voltage is the same voltage as the base emitter voltage of this transistor Q3. So when this base emitter voltage increases, this transistor starts conducting more, and the collector of this transistor is connected to the base of the series pass transistor. So it starts conducting the base current of series pass transistor away. So since the base current decreases, the series pass transistors conducts less. In this way, the current is limited. Now let us look at the next protection circuit called safe area protection. SOA. As I said, safe area protection makes sure that the difference between the input voltage and the output voltage does not go beyond a certain limit, which means the difference between the collector and the emitter of this series pass transistor does not exceed a limit. So as long as this difference is not exceeding a limit, the current will pass through Q1. But if it exceeds a limit, then this Zener diode starts conducting, and the path of the current would be this way through Zener diode ZD, R1, R2 and R3. Once more, when the difference voltage between input and output increases, this Zener diode starts conducting, and the path of the current will be through the Zener diode, resistor R1, resistor R2 and resistor R3. Now as the current across resistor R3 increases, the base emitter voltage increases, and this transistor Q2 starts conducting, and it will drive away the base current from the series pass transistor Q1 and thus remit the output current. Now the safe operating area protection circuit operates at a rate which is given by this formula, that is the change in the output voltage divided by the difference, the change in the difference between input and output voltage, which is equal to the ratio of resistor R2 by resistor R1 and R3. So the SOA protection thus reduces the output current in case of input output differential voltage increases, and limits the regulator operation within the SOA, that is safe operating area of this transistor Q1. Now thermal overload protection. How would the IC protect itself against an increase in temperature? As opposed to discrete circuit, this protection is easier in a monolithic IC because everything is close to each other and it is easier to sense the temperature. Now this transistor Q3 does the function of thermal protection. So this transistor Q3 is placed as close as possible to this transistor series pass transistor Q1, and it is biased in such a way that if this temperature here increases, then this transistor Q3 will start conducting. So as the temperature increases to a dangerous level, this transistor Q3 will sense it. This base emitter junction voltage will increase and this will start conducting, and the collector of this transistor Q3 is also connected to the base of the transistor Q1. So Q3 drives away the base current of the series pass transistor and thus decreases the flow of current here. So in this way, transistor Q3 protects the circuit from thermal overload. Now let us come to this error amplifier. We come back to the block diagram of the IC series regulator, and in this you have the error amplifier here. As you have seen, that error amplifier amplifies the difference between the reference voltage and the feedback voltage. This error amplifier may be single stage or multi-stage depending on the requirement and depending on the designer. So this error amplifier works in a negative feedback mode, and the reference voltage is connected to the non-inverting terminal, whereas this feedback signal is converted to the inverting terminal. The output voltage of this error amplifier Vout is given by this formula. Vout is equal to Vref, that is the voltage supplied by here, voltage reference, into A, that is the amplifier gain, divided by beta. Beta is the feedback factor into 1 plus A. Now usually the value of A is a huge value, a large value. So A can be approximated to A plus 1. So in this way this A and this A plus 1 gets cancelled out, and this equation reduces to this form: V out is equal to V ref by beta. Now the feedback factor can be 1 or can be less than 1. When it is 1, V output of this error amplifier is equal to the reference voltage. Now series pass transistor. This is the series pass transistor. The maximum current, the load current that you want it to pass, and what will be the maximum input voltage, that will determine what type of series pass series pass transistor, its size is required. This transistor is built inside the IC, due to which it is easier to protect it from thermal and overcurrent or short circuit. Now the ICs which have this series pass transistor inside it has only 3 terminals: input, output and the common ground terminal. Now you have seen 2 circuit diagrams. One is this one, which we use to explain the protection circuits, and another is this block diagram of the internal arrangement of the ICs. Both of them look different, but they are actually the same circuit which is arranged in a different manner, and different things are highlighted. So here Q1 is the series pass transistor, which is the same transistor which is shown here. This is the error amplifier. That error amplifier is shown here. This is the reference voltage. This reference voltage is shown here. Constant current source. That constant current source is shown here. Protection circuit. This protection circuit is just shown in one block diagram, but which is elaborated here in terms of Q2, R2, R3, R1, Zener diode and Q3. These all 3 protection circuits are just shown in one block diagram over here. The startup circuit is not shown here. So in a way both the circuits are the same, but we have drawn it in different ways depending on what we want to emphasize and what we want to explain. Thank you.